All right, we're moving on to session 2 for lesson 4. We're still going to continue breaking apart how to multiply multi-digit numbers, and we'll start with a warm-up for today. These are the previous questions from yesterday's classwork, and here's today's warm-up. Okay, for the warm-up, I thought it'd be a good idea to go over how to multiply multi-digit numbers when there's zeros involved. It's actually pretty easy once you get used to it. The first step to do is I'm just circling here so you can see it, but take those first two numbers and multiply them together. So we know 3 times 2 is 6. And then see however remaining zeros you have left over. In this case, just that one. And then kind of add it to the right-hand side of it like that. So 3 times 20 is 60. Let's look at the pattern here as it goes further. 3 times 2 is 6. Now we've got two zeros. So 30 times 20 is 600. 3 times 2 is 6, and then take 1, 2, 3, take those three zeros, it gives us 3,000, or 6,000, excuse me. So when you see numbers this big, there are ways in which you could do them pretty accurately, pretty quickly. However, sometimes this happens. So let's look at 4 times 5. Now that gives us 20. Now, sometimes kids will see that and go like, well, if there's one zero here, so there's already a zero right there, so I must not add anything. When actually, that 5 times 4 produced that extra zero right there. So you will still have to put that down and then bring your zero over like this. Down here, 6 times 7 is 42. No big deal. Give us two more zeros. And this one, 5 times 2, gives us a 10. So again, a new zero is produced, and then we take on the zeros left over from our factors and put those in there like that to give us 10,000. So again, just a nice trick to do these more quickly and accurately. All right, so now we've got that. Let's go and look at the notes on page 59. And the notes for today are going to involve us kind of breaking apart multi-digit multiplication problem a little more and kind of see how it works. So the scenario is 128 pens in a full box. How many pens are in 35 full boxes? So we could draw out 35 boxes and write 128 on them and then have a gigantically long thing where we add up 128 35 times. Or use multiplication. Again, multiplication's whole purpose is to make our addition go faster. So here's 128 times 35. Okay. But I want to use this space to kind of explain to you how this works and why it works so fast. So I'm going to tear apart that 35, one of those factors. I'm going to change this to 128 times 30. And then over here, I'm going to have 128 times 5. So as you can see, I took that 35 right here and broke it up into two spots. Now the reason I did that is to kind of help us understand that this 3 right here is not regular 3, like 3 in the ones place. That 3 is actually in the tens place. So that 3 actually equals 30, like it does over here. This 5 is in the ones place, so that is just plain old 5. But we're going to create some partial products from this and then combine everything to just kind of show you how everything breaks down. So 0 times anything is 0, so we're not going to bother with the 0. But let's do threes like this. So I've got 30 times the 8. This 30 right here times 8. And just like with our warm-up, 8 times 3 is 24. I've got a 0 right here. So that gives me 240. Then we have 30 times this 2 right here, but that's not a 2 because the 2 is in the tens place. So that's actually 20. So 3 times 2 is 6. I've got two zeros. That gives me 600. And then we have 30 times this 1, but the 1 is in the hundreds place. So we're actually multiplying it by 100. 3 times 1 is 3. And I've got 1, 2, 3 zeros here to give me 3,000. So if we add all those up, we have 3,840. Over here, We'll keep things simple. We'll do 5 times 8, which equals 40. And it's 5 times the 2. Now the 2 is in the tens place, so that's actually 20. 5 times 2 is 10. Tack on that 0, that gives us 100. And we have 5 times the 1, but that's actually a 100. 5 times 1 is 5. Add on those 2 zeros, it gives us 500. Add all these up, it gives us 640. Now, I noticed on a lot of the classworks yesterday, we get these partial products like this, but we forgot this last step where we combine them. So if we add 3,840 plus 640, we got 0, 8, 14, carry the 1, 4,480 pens. So again, this is not the ultimate way in which we want to do our multiplication. There's no way, because it'd take too much time, but this is breaking down how it all works together. All right, so go ahead and turn the page. And it just, these 2 pages here, these 2 examples are just showing us some things that are going to work with our notes. But here's the area model, which we did with our classwork yesterday in our notes. And this is the way that we did it earlier. We're using this distributive property right here. Find the partial products for it. So there's that. Let's look over at the notes on the next page. All right. So for number 1, why is the area model divided into 6 sections? That's the one under model, that first one. It's in 6 sections because 6 sections for the 6 partial products. And partial products, again, are those numbers that are underneath the line in our multiplication problems. How do the 3 partial products in each multiplication equation in the second model relate to the 3 sections in each row of that? Well, it's simple as that. Let's kick back here. So look at this. You want to look at these right here. Keep an eye on those. Circle those in your book. And then we've got these right here. They are one and the same. So how they relate to each other is this way. The top row is 3,600 and 240. Bottom row is 500, 100, and 40. So those all equal the same. So our first example we did, these 3 partial products were the left-hand side, and these 3 partial products were for the right-hand side. Use the partial products 3,840 and 640 to find the product. Again, what I'm talking about here is making sure we do this final step where we add up our partial products to get our final product. Partial means it's not all together, so you got to remember to do all of it. And it gives us our 4,480 pence. Would the product change if 30 and 5 in the left side of the area model were changed to 20, 10, and 5? No. And let me explain why. Because that totaled up to 35, and these total up to 35. So if they total up the same amount, only the partial products would change. Something to keep in mind. List 2 different ways you could break up the factors 239 and 64. Now I don't have a lot of space here, so I'm only going to do one. But 239, we break that up into hundreds, tens, and ones. And then for 64, we break that up into tens and to ones. There's other ways we could do it, but let's just break it up the easy way and deal with that. Go ahead and cross off number 6. We're not doing that one, and turn the page, and we'll do 7, 8, and 9. All right, find the product 120 times 25 times 40. Does it matter what order you multiply the numbers? So no, it does not. Even if we're using bigger numbers, the order's not going to matter. We could do 25 times 40, 120 times 40, 25 times 120. It's not going to matter. But for the sake of this one, let's do this and split your work area up into 2 parts. So we have 120 times 25. So let's figure this one out. So we'll do our 5 first. We know 5 times 0 equals 0. 5 times 2 is actually 5 times 20. That gives me 100. 5 times 1 is actually 100, since the 1's in the hundreds place. And let's go with our 2 here. Again, the 2 is actually a 20. 20 times 0 is 0. 20 times 2, that's actually a 20. Remember, 2 times 2 is 4. And bring over your 2 zeros. And then the 20 times the 1 is actually 20 times 100. So 2 times 1 is 2. And then tack on those 3 zeros. And all of these add up to 3,000. Then we still have to deal with this 40 right here. So then we bring down 3,000 times 40. And let me show you what I'm going to do. It's going right back to the warm-up. I've got zeros in both of these, so I'm going to do a little trick here to save us time. 4 times 3 is 12. Then I have 1, 2, 3, 4 zeros. And then I get my final answer of 120,000. So, and hold on to that number because we're going to need that for the next question. But remember, like I said, over here on the right, if you got 2 numbers with that, you can just multiply them and then put on your zeros. For this next one, find the volume of the rectangular prism. So this is a reminder of what we did last time. So you have length times width times height, but you'll notice that all 3 of these numbers are exactly the same numbers that we used in the above problem. So we've already done the work. Just we have to be careful with our final answer. So my final answer is not just 120,000, but look here, it's got to be cubic centimeters. So when I teach you something, we usually do come back to it. It's not to teach it to you and then we move on to something different. So you need to remember that. And let's do this last problem. Library bookshelf holds 156 books. There's 15 bookshelves in a certain section library. How many books can the library place on these bookshelves? And show your work. So over here, let's write what it would be if we just set it up the standard way. But I want to split this up into 2 parts. We're going to do 156 times 10. And then we're going to have 156 times 5. So what I can do for this one, I can take 156 times 1. Give me 156 plus a 0. Over here, I don't have any zeros in my factor, so I can't really do any tricks to save me time. So I've got to do 5 times 6 equals 30. I can do 5 times 5, which is actually a 50. Gives me 250. And then 5 times 1, it's actually 100. Give me that. And then these all add up to be 780. Now I'm not done yet because these are partial products. We need to actually add them together to get a final product. And let's give us this. 2,340 books. All right, so a little longer notes than normal, but again, if you're taking these from home, you could pause or rewind if you needed to. But the classwork for today is multiplying two digits, so it's 2 by 2 digit numbers. Again, remember to, when you submit it for Kami, make sure you're not only giving me the partial products, but also give me the final products as well to get full credit for today.